In this episode, I am going to talk about the switch statement, which is another conditional statement very similar to the if statement. However, first of all, let's recap what I showed you in the last episode. Actually, in the last one, I covered a lot of ground, I think. I hope this wasn't too fast for you. So let's shortly recap. First of all, I showed you this new way of defining an array. So like the traditional, let's call it the traditional one, was this one, where you just said person, square brackets, persons equals to new person of 4, which is with size of 4. So this can hold 4 elements starting at 0. Well, this needs a lot of lines, and this actually is the short form. Just with the curly braces opening and closing, and with a comma-separated list, you can define an array. And my recommendation is end with a comma at the end, so that you can easily extend the array at a later time. Also, I introduced a new modifier for variables, the final modifier. The final modifier kind of protects a variable for us. So what it does is, when in a later line I try to assign something new, like let's use this area on top here, this is not going to work. Cannot assign a value to final variable persons2. Also, we can try to assign null, which is like emptying the variable, will also not work. This is nice-ish, however, I personally prefer to not use it locally in a method, but instead to use it for static final variables that are used read-only and are defined at the top of the class usually, like this here. I hadn't set any modifier, so this at the moment is default visibility. Usually I would prefer it like having it private, and if you need other classes accessing it, I mean, this is supposed to be read-only, so it would be okay-ish to have this public. However, even better, if you really want to focus on clean code like I do, you could provide a public method returning the string array. I don't know, some name. Let's call it states. And in here, well, first of all, let me finish this. We could copy this array, because with a copy, if someone else, because the final, what it does protect is, as I said, the variable. What it does not protect is the content. So it's safer if we return a copy of the array. And there's actually a helping class which provides of Java util, which provides some static methods. And really have a look. See, we are going to use the copy, but there's also many more methods, like here for doing a binary search and so on. This is really a big toolbox of methods that you can use. Play around with them, and I might show some of them at a later time. For now, let's use the copy of. And then we take the array, and we have to state the size, which again we take dynamically, array.length. Yeah, we also talked about this. So this is dynamically returning the length of the array, which in this case is 3, because the array has 3 elements. So this is really a nice way of generating clean code and returning this array. Also, I told you it's all in capital letters and using the underscore and not written in camel case, because this symbolizes that it's a static final. So in short, you just talk of a static final, because this is how you write it. Okay. Let's go back to the bottom. So not much about the array. I also very shortly talked about equals because I had to, because for two strings like ABC, and if you want to compare them, you cannot do so with the double equals. This is not going to work, even if it's the same, because the problem is that this comparison does not compare objects, and this is an object. Instead, it compares the reference variable. So equals does work for int 3, and then you can say 3 equals I, because the 3 is actually in here. But if you have a string, let's make it null for now. In here is not the object or null. In here is the reference, which is something you can think of, something like a number also, will be saved in here. And when you compare with the equals, with the two equal signs, then you compare this variable, which means you kind of compare if it's exactly the same. So what will be true is if you would say my string equal my string. But this usually is not what you want to say. And so when you compare two strings, you have to say equals. Talking about equals, usually in one sentence, you should always also talk about the hash code method. This is already a very advanced topic, so let me keep this very short for now. It's just that if you create a new class, like I created the class person, it's often a good idea, well, it depends, but you might want to implement the equals method in your person object so that you can compare two persons. But if you do so, you also have to implement the hash code method. What the hash code method is and all the details I will explain at a later time. Okay, so that much about the string comparison. Oh, one more thing. I made this now because I also wanted to make a point. What I see very often is people that would write equals like this. My string dot equals and then a static value. This is not so nice because as you see, this might be null and then this throws an error. And of course, we don't like errors. So instead, always put a value in the front which will never be null, like this string here. I mean, this is ACB as I wrote it down, and it will never be null. So ACB equals null will just return false. But null equals ACB will always throw an error. Okay. So let's stop here. Then, actually the biggest part of the last lesson, we talked about enums which are introduced. I created this enum here, logging level. Let's go to the class. So public enum logging level I defined. Actually the name is a bit awkward because it's not a logging level. I was thinking of something like info warning an error, but then I decided we haven't talked about logging either, so I instead took pending processing processed. So this would be more like a status, but I don't know, let's leave the name for now. It's just a stupid example. So this is the enum that I introduced. which is a bit similar to a class, but has some limitations, but also has some features a class does not have. So it allows us to define these static, let's call them labels, that we can act upon in our code. So we can say if something is pending, do this or that. So it's not only more readable, it's also more safe. Enum was introduced with Java 5, and before that people would have taken numeric values like if something is equal to 0 or 1, but then already people started to calculate these values. This really gets nasty and problematic, and I'm not showing you this because I want you to do it in the proper way, and that is using an enum. So this is really a cool feature. You don't have to, also introduce a constructor if you want to have extra values for each enum value, and you can provide methods that would return these values or do whatever you want. Which I also like to make the code more readable is I often provide, I mean not always, whenever you code and you design your code, always think your decisions through. Don't make a decision just because. This is never smart. So if for whatever reason in the code you work on, for example, the pending value and you need to ask, is it pending? Then it might be nice to add this method, is pending. And then you can say return this, which is the enum, and not only the enum, but the current value of the enum equals pending. So if in the code you have an enum, let's do this, logging level, still I call it state or status, equals logging level. Now I take processing, and then I could say if state dot is pending, which now would be false. Some code would have to be executed. But what I want you to know is only add such a method if you really need it. So it would not be wise to always by default provide a method for each of these values. People usually get lazy, and when they see something is working, they tend to just overuse stuff, and they just like, I might need this, so let's just add a method just because. No, never do that. Never add a method just because. Always think it through. I mean, code lives, and you can always change your code later, and you always can add a method later. So only add it when you need it. Let's say now we don't need it, so we will also remove it. Okay, I think this pretty much rounds it up for enums. Actually, they allow much more crazy stuff, like each value could have their own method implementations. I hardly ever use it, so let's not show this for now. I think this is pretty much what you need usually. And now let's finally actually go to the topic of this lesson, which is the switch statement. So I think I already a bit introduced it in the last lesson. I said we want to shorten this here. So the switch statement is also a conditional statement, and that's pretty much exactly the same like these ifs here, just in a shortened form. Okay, I mean, don't think about the exact meaning here. This is just pseudocode to explain you something. Okay, this time I will not use the for loop. I will directly operate on this state here. And then we can, instead of saying if, we can say switch. So we are operating on that value here. And then instead of if, we're saying case. So if it's the case that the state has this or that value, case pending. So this is the same as saying if equals pending. If you just have one, then an if is of course shorter, but the switch statement is usually used when you iterate through all or most of them, because you have this extra of saying switch, but then the more states you have, the easier or shorter it will get. Processing case. Processed. Now imagine we would have 100 different ones. Let's format this. Now what happens is I haven't put any method here and I have not put a break statement here. So actually what would happen here now, let's put the same method call. I mean, I have not implemented the method, just imagine this was a method. So for all these three different states, oh, there is a column missing, we would call this method. If, imagine we use a switch statement within a private method, you could also like return a value. So this depends. The difference with a return is when you return something from a method, of course you also leave the method. While I'm pointing this out is because normally, usually, what you want is you want to do something, and it might not even return something, like printing something on the console, and you would call one method, and in here you would call a second method or do a second something calculation or so, and here a third one. Now it gets problematic if you forget the break, because what then happens is a fall through. This will be called as well as that will be called. So this is really a big source of bugs, very, very dangerous. So in this case, never forget the break. And if sometimes you want to have them together because you want all the three of them, for example, or two, to call a certain method, it's recommended to leave a comment falls through so that you tell the next programmer, I know what happens and I did this on a purpose. Okay. So that much about fall through. And you don't have to set all possible values. You can also leave one out. If nothing is found, in this case, we would just leave the switch statement and would just not do anything. What you can also do is, you always have the possibility to adding a default, which will be called if none of the other case statements apply. And then people sometimes say, I don't know, call default method. Well, here I really want to warn you, and of course again we had fall through, would have to say break. This is not so wise. The problem is, I mean, code lives, and who stops the next colleague from extending your enum, adding, for example, an error state here for and some text. Your colleague would just do this, would not know there is this switch statement, and now you implemented the switch statement, you didn't think of the error case, and the error case might need a specific behavior, but now you would also call this method for this new error flag. So usually we don't want that, so what I recommend you for the default statement, either you don't use it, or even better, use it, But here you would throw an error. You say, I'm not doing this now because I haven't talked about exceptions yet. We will do at a later time, but this is the place where you would have like an exceptional case. And the good thing about this is when someone extends your enum and this someone forgets to extend also one or more switch statements, you would see this. I mean, you might say, oh, but then my program crashes and this is so nasty. Well, of course it is, but there is a rule in good design, and this is called fail early. It's always better to have a high severe bug on production even, and to have to fix this within, let's say, seconds or hours, than to have a high severe bug and no one notices it. Because if it would not throw an error, it might calculate something in a wrong way, but a client might notice this, let's say, 3 months later. And then the problem will be so much bigger. So when programming, sometimes you just have to be brave. I also see people that try to prevent errors and like return something, for example, return null. So this is actually just, instead of accepting I have done something wrong and let's fix it, this is just like putting the problem to the future and making it bigger. So I want you to be brave and throw exceptions and handle them then. This is always better. I mean, I'm not saying you should program buggy code. Of course, we should try and concentrate, but sometimes bad things happen, and then it's always better to fail early, and so you notice the problem and you can fix it. This is always better than hidden bugs. Okay, I hope you got my point. Okay, so also here, well, if you have an exception, you don't need the break because an exception always leaves the block. But what is important to always have a break, or like here, where you don't have the break, leave a comment false true to tell the next programmer, I know what I'm doing, I want this. And talking about warnings, one more thing. Don't overuse switch. As well, don't overuse the if statements. These conditional statements, you see how much the code grows, also in combination with for loops, and see how many levels this adds to the code. You have to understand this switch. And then there is different case statements or default. And then inside of the case statement, there might be a method called, and so on. So this really complicates the code. Same as with the if statement. You have to see what is the condition for me to enter this block. Aha, then this method is called. You might click to the method. You might want to check here. So this all makes it more complicated. And actually, this is also like a, let's call it a relic from the past. This is what we call procedural code, because it's like a procedure. It's like really, this makes you thinking like a machine. Like a machine would switch a state, would say case this, do that, case this, do that. But humans usually don't think like this. And the cool thing about object-oriented programming is that the object-oriented programming is very close to how humans think. And this allows you to like talk to business guys, and this really makes your code nice. And switch is not object-oriented. There are some cases, corner cases, where it might just be easy and fast to use it, but don't overuse it. Really, I mean, there are people that would have maybe hundreds of lines in here. This is just crazy, really hard to read. This is also why I had here a method. This is not yet perfect, but still better than just having huge switch statements. There are techniques. For example, just shortly, you could have an object representing the pending state and an object representing the process state, and so on. So there are advanced techniques of how to prevent a switch statement, and it always depends, like what's better. For very small switch statements, it might be okay. Just remember they are a bit like evil and should not be overused. Okay, I hope I have added enough warnings of switch and if statements. This is also one reason why I'm only introducing it now, because I really want you to become an object-oriented programmer. And yeah. Okay, so I think this pretty much rounds it up for this episode. I hope you enjoyed it and were able to follow my explanations. As always, I'm very happy if you can leave me a comment below this video, or just click on the like button on the bottom right of this video. And yeah, hope to see you next time.